This lesson is over factoring quadratics. This is a concept you learned in Algebra 1, so we're going to review it so you're prepared to factor some of the more difficult things you encounter in Algebra 2. The standard form of a quadratic is ax squared plus bx plus c, where a, b, and c are just real numbers. Quadratic equations form a parabola, which is that U-shaped curve either facing up or facing down, opening up or opening down. And we can change from the standard form of a quadratic that you see here into the factored form of a quadratic just by factoring. And factoring we talked about earlier in the week, but what that is figuring out what two quantities, when multiplied together, make this product. A way I'm going to teach you how to factor, or maybe remind you how to factor, is through this X model here. It's basically just an organizational strategy to help you figure out what two factors multiply to make your standard form. The X model, what you start with is on top. You're looking for numbers that multiply to make A times C, and you're looking for numbers or factors that add together to make B. When we think about if we were starting with factored form, the way we would get to the B term is by adding common terms together. And the way we would get the A times C, or our C value, is by multiplying terms together. So it makes sense that it's the product of AC while adding to make B. So let's try a few problems and see how we do. Here's our first one if you want to write down this problem. And again, feel free to change these V's to X's if that makes it easier for you. So I always like to identify what my A, B, and C value are first. It looks like our A value is 1, our B value is -2, and our C value is -8. So we're looking for numbers that multiply to make A times C. And A times C in this case would give us -8. So we're going to put a -8 here. And our B value, again, is -2, so we're looking for numbers that add up to make -2. What goes to the right and to the left of the X is the two factors that multiply to make -8 and add together to make -2. Those two numbers are -4 and 2. -4 plus 2 makes -2. -4 times 2 makes -8. If you struggle to figure out which one was positive and which one was negative, just remember that the sum in this case was negative, so you knew your negative number had to be a little bit larger. As far as the product being a negative number, anytime that happens, you know your two factors have to be opposite signs, because the only way to get a negative product is if you have a negative being multiplied by a positive number. So your final answer of factoring this trinomial would be x minus 4 times x plus 2. I'm only going to show this one time, just as a way to actually check your answers to determine if you're right. All factoring problems are self-checking. So if you use an area model to show the expansion of x minus 4 times x plus 2, you'll find you get x squared minus 4x plus 2x minus 8. And when I combine like terms, I get x squared minus 2x minus 8, which is exactly what I started with. Let's try another one. So here for this problem, let's identify A, B, and C. We know our A is equal to 1 in this case, B is equal to 5, and C is equal to -6. So we're looking for numbers that multiply to make A times C, which would be -6, and add together to make B, which again is 5. So think about the two factors that multiply to make -6 and add together to make 5. Those two numbers are 6 and -1. Whenever you notice a difference of 1 between the product and the sum, you know that it's going to have to be multiplied by 1 of some kind. Just start to recognize patterns like that. Our final answer of m squared plus 5m minus 6 factored would be, you're going to find that I write x's way more than m's or any other variable, would be m plus 6 times m minus 1. We just took the standard form and changed it to factored form. Let's try one more. So for this quantity here, let's identify quickly what our A, B, and C are. Our A is 1, B is 4, and c is negative 60. So we're looking for numbers that multiply to make negative 60 while adding together to make 4. So if we make our x model, think about what two terms multiply to make negative 60 and add together to make 4. Those two numbers are 60, not 60, excuse me, 6, be way too big, 6 and 10. And I want you to think about which one would be negative. In this case, it would be the 6 because we have a positive sum in that case. So our trinomial factored would be x minus 6 times x plus 10. Sometimes you'll have a special case quadratic, which we're going to look at here in just a moment. It'll look like this right here. Now, just at first glance, this quadratic looks exactly the same as all the other ones that we've worked with. So what makes it a special case is something we'll notice here in a moment. Kind of maybe preview the thought here. It says perfect square trinomial. So we know what perfect squares are. Let's see if we can make a connection between perfect square trinomials and something like this. Identifying our a, b, and c value. A is 1, b is 8, and c is 16. So we're looking for numbers that multiply to make 16 while adding together to make 8. And those two factors are 4 and 4. So to write out this trinomial factored, we would have x plus 4 times x plus 4. But notice that those two quantities are the same. So this is a perfect square trinomial. We can rewrite our answer as x plus 4 squared since we have the quantity multiplied by itself again. Another quick way to identify perfect square trinomials is that your c value will be a perfect square. Your a value, which in our case was 1, will be a that looks like 111. Our a value is a perfect square, which is 1. And your b value is twice the square root of a times the square root of c. So a and c are perfect squares. And your b value is equal to twice the square root of a times the square root of c. That's how to identify it. Let's try one more perfect square trinomial. Again, identifying our a, b, and c. We know that a is equal to 1, b is equal to 10, and c is equal to 25. We're looking for numbers that multiply to make ac, which would be 25, and add together to make b, which is 10. We know since this is a perfect square trinomial that these two factors have to be the same. X plus 5 times x plus 5 to make x plus 5 squared. The last ones we're going to try have to do with GCF. We talked about that yesterday. Initially, when we look at this, I don't know how to factor this, or maybe I can't remember how to factor this. We do know how to. We might just need a reminder, which is what we're doing next week. So we need to look and see if there is a GCF that we can factor out between these three terms. And as I look at those, I immediately see a 3, 6, and 9. So I know my GCF is a 3. If we factor that out of this expression, we end up with this. Now, seeing that my a value is 1, I can follow the same model as I had before. I'm looking for numbers that multiply to make negative 3 and add together to make 2. So those numbers would be 3 and negative 1. So my final answer for this expression factored is 3 times x plus 3 times x minus 1. Same concept here. I look, my greatest common factor is a 5. So I have 5x squared minus 7x minus 8. Looking for numbers that multiply to make negative 8, but add together to make negative 7. So in this case, we would have 8, or negative 8, excuse me, and positive 1. Keeping that 5 out front, because we factored that out of the expression, we have 5 times x minus 8 times x plus 1.